title. It's about reliable and secure DHCP. Can any of you give me a very quick definition of what means reliable? We certainly have an understanding what is secure, or what it should mean, right term. What about reliable? What do you refer to when you attribute something as reliable or acting reliably?
Fit for function, working as intended.
Wonderful. I owe you something, man. Working as intended. Keep this in mind. The very simple expectation we might have when it comes to DHCPv6 is it does what it should do. And here comes, as we will see, the first part of the problem, which is a huge part of the problem. Yes, I will tell it. I don't have to introduce myself, probably. So let's go through some quick disclaimer. When I and my colleagues, when we give IPv6 workshops, obviously DHCPv6 is part of those workshops, and that's usually the most unpleasant part. For the simple reason, it's what I think, I wouldn't say broken, but it's a very, DHCPv6 is different than DHCPv4. Let's phrase it for the moment in that neutral way. And especially for the people we talk to, then they start scratching their hands and they are like, seriously? Wait a second. This is what it's supposed to be, next generation protocol? And they look at you and, I mean, at that very moment, the guy standing in front is the guy who has to deliver the message. I will deliver a message which will not always be pleasant, especially for those of you from enterprise space here, which is the main audience for this talk. That's the reason for this unpleasant state. I somewhat refer to the reason on that slide, but please don't shoot the messenger. I'm just telling you some things about DHCP and reality, and well, those things will not necessarily always be like music in your ears. The agenda is pretty simple. Let's discuss for a second what is DHCPv6 and how does it work. So I will introduce some basic terms and terminology and technical stuff. Then let's focus on what do you usually, or what do enterprises or organizations thinking about DHCPv6, what might they expect? Like, we want to use DHCPv6 for this and that. Let's figure out what are the expectations and if those expectations can be met by the way how the protocol is implemented. And last but not least, it's always, our talks is not about just ranting or describing something, but what does this mean for your environments and how could you, what can you do actually, what does work and what doesn't. Getting into DHCPv6, it's initially specified in RFC 3315. The number itself is not important. What is important is RFC 3315 is quite old. I would say I never looked it up, but it's probably still in the 90s. So it's like the main specification is like 15-year-olds. There might have been a different understanding of networks at the time. It uses different ports, 546 and 547, which will come into play at some point later on. It's multicast based instead of broadcast messages, as the whole architecture of IPv6 is clients and servers identify themselves and information they exchange by means of certain identifiers. One of those, the DUID, will be important for us in a second. Other than that, the main architecture, there are clients, there are servers, there's relays which can transport messages. There is two multicast groups used within DHCPv6. The main one is FF02, double colon 1, column 2. That's the one you will usually see in the interactions, and there is another one which can be used like once a relay. Relays messages that can come into play. The addresses in itself are not that important, it's just keep in mind it's multicast. What is important for many like enterprise organizations or organizations, all organizations using DHCPv6 is the concept that the entities involved in an interaction are no longer identified, or the server does no longer identify a client by the client's MAC address, at least not by the main specification, but the servers and clients identify themselves by a DUID, a DHCP unique identifier, and this DUID can be generated as of the main standard initially by 3 methods, and another one was introduced recently. So there's 4 ways to generate this DUID, which is supposed to stay the same, consistent, during like the whole life cycle of a system. So this is not renewed, this is not once ever rebooted, it's another one. It's created once, and it stays with the system for the whole lifetime of the system, which is part of some problems, as we will see later on. This DUID is mainly looks like this. It's usually a 128-bit value, which in actual reality on Windows, just to give some examples, it's starting a registry. It looks, you can see it's here. There it is on certain Linux, depending on the flavor and the DHCP client software running. It's a value of DHCPv6. DHCPv6 DUID. So fixed value supposed to stay with the system during the whole life cycle and identifying this system uniquely, which in itself is a good thing, but the way how this DUID is generated might unfortunately come into play as for the way how DHCP works. What should be kept in mind for a moment is the default generation mechanism on most operating systems is the so-called NLT type, which is generated DUID based on number of seconds passed since I think 1st of January 2000 plus and concatenate that with the MAC address of one of the system's network interface cards, which is not necessarily the one that is used for DHCPv6. So for example, a Windows system might generate the DUID, take this timestamp, add the MAC address of the Wi-Fi interface, where and later on DHCP is mainly used like on a wired interface. So even then, if you try to, oh wait, the MAC address is in there, it might be the wrong one. All this will play a role later on. There is several message types which are somewhat similar to the message types used in DHCP before, but they have different names. And there are some new message types, there are some that have been deprecated. So overall, as we will see, the main principle is the same one, but all the interactions have, or many of the interactions have different names and different fields, and it's a fully different concept. Still one could say, well, okay, I just have to understand those names and principles, but in the end of the day, it's DHCP, isn't it? We will see if that holds. I can mostly quickly skip over this. This is more for documentation purposes, just to have some basic understanding of DHCPv6. Let's get into this one in more detail. What are the main differences from a technical perspective between DHCPv6 and DHCPv4? The first one that probably most of you know anyway, as this has been in the IPv6 world, full of debates and discussions and claims and religious arguments. This has been probably the biggest one during 10 years. DHCPv6 does not have a route option. This means that you can't provision or distribute a default route by means of DHCPv6. This leaves a number of people scratching their heads. I won't go into this debate in this talk, as then we can spend the rest of the talk just take it as it is. There is no way for DHCPv6 right now, and I don't think this will change, at least not as long as Bob Hinton is area director of 6-Man. Hopefully this is recorded. Yeah, no route option. The second one, as we already, or as I laid out, is this concept of the DUID, which is a different concept of identifying players, which at least is different from identifying clients by means of the MAC addresses, which has been around in DHCP before. Another technical difference, and one that is, I think, usually very much overlooked, and actually I think this is the one that will hurt most enterprises badly, is what I call the non-role of DHCPv6 and IPv6 subnet model. There is an ROC. It's a mostly theoretical ROC, but it's just one that you certainly have to know if you think about bringing DHCPv6 in your environment. That's 5942. It's a theoretical one. It describes the so-called subnet model of the IPv6. The main thing as for DHCP is once systems perform neighbor discovery, like we have Alice and Bob, both on the same local link, and Alice and Bob are supposed to be able to interact with each other. What would you expect happens if Alice wants to communicate with Bob? Alice gets into a neighbor discovery process, sends out a neighbor solicitation, asking like, okay, sends that to the solicited node, multicast address, all this stuff you probably know, asking, okay, I have to identify Bob. Bob, can you please get back with your MAC address to me? This neighbor discovery process is only started, technically speaking, if there is some, like the prefix that Bob has, or the address information, somewhat in one of the, say in the routing table, which is only the case, and now comes the interesting part, if the so-called on-link flag is set. Is set. Who of you does not have an idea of what the on-link flag is and what it does? There's only 3 or 4 people. I mean, let's simplify it in that way. One could call it like the I'm on a shared link flag as well. It provides an information, an address that is used. And in IPv6, systems can use many IP addresses. It tells if it's about this address, assume that the link where you use this address is one that is shared with other entities. So it's a shared link, which means you can communicate with other entities, or simply said, there is neighbors on this link. And this flag has to be there to enable systems to perform neighbor discovery. If this flag is missing in the address information on the local system, they won't perform neighbor discovery. As they have the impression, oh wait a second, I have an address, but the flag telling me that this is a shared link is not present, which in the end of the day means, well, I'm pretty much alone on this link. Ivan referred to this in his yesterday talk, as he said, okay, if we clear the on-link flag, systems will be of the illusion, which might be the technical implementation or not. In Ethernet it's not. Ethernet is a shared medium. But they might still think, okay, I'm alone here. The only party I can communicate with is the router. So if the on-link flag is missing, systems will not perform neighbor discovery to talk to neighbors. They will be under the impression there's just the router to communicate with. If the on-link flag is missing, and those two want to communicate to each other, they won't do so in a direct manner. They won't even send out neighbor solicitations. They will communicate with the router. If Alice wants actually, I will show this in a more detailed way. We will look at some packets soon. Okay, I already covered this. No route option, which has the consequence that whenever you want to fully provision a system by means of basic IP parameters, which is, okay, maybe here's an address, here's a default route, and here's DNS information. That's what usually systems need to be able to roughly communicate, just somewhat communicate with other systems. To provision this information, you always need at least some other entity providing the default route, which is supposed to be, in the IPv6 architecture model, to be a router by means of a router advertisement. But of course, thinking about this has operational implications, as it means simple provisioning of systems cannot be done from one source, but there is, in most networks, there will be several sources run by several parties be involved. The concept of UID, I already mentioned this. The main consequence on a technical level is all the stuff you might have been doing in DHCPv4 based on a MAC address. That might be reservations, like in a data center. Certain systems always get, even though DHCP is there as a central address provisioning system, some systems always get the same IPv4 at that time address based on the MAC address. That's called reservations. Very common mechanisms in a number of enterprise networks. There are networks which use like DHCP as what I call a poor man's access control. They just hand out DHCP addresses to systems with a known MAC address, which can be looked up in a CMDB or in some type of database. Usually as for logging and monitoring purposes or in provider networks, there is a need to correlate to know, okay, this system, in the log files we see IPv4 Communication Act and we see IPv6 based Communication Act. We want to correlate them, we want to be able to identify, okay, this was one single system working with two different stacks and maybe different addresses. The MAC address can be an identifier for this correlation. So there are several purposes where the MAC address is useful. All these, for the moment, are done with DHCPv6. You can't do this any longer. There is a queue for this, RFC 6933, but that's not yet widely supported. It would be a feasible way going with RFC 6933, 39, supporting entities to solve these types of problems, as we will see later on. And that one I already mentioned, this subnet thing. Let's have a quick look at a system I have here. This system right now has two IPv6 addresses. For the simple reason, it's in there is a router providing stuff, and this one has a very, very simple configuration, which goes like, okay, there is a DHCP server configured on the router, which essentially hands out addresses from a certain prefix, 2001 DB8 22/64 prefix. It hands out a DNS server, and what is of further interest is the configuration on the interface. The M flag is set, which means in the router advertisement, actually there's a flag which tells the systems, go out, look for a DHCPv6 server and get information from that one, and given it's the M flag as opposed to the O flag. Get an address, get a full set of configuration, get whatever the server can provide. Still, there is router advertisements, originated from, they come from this, actually from this interface, from the router, and on this link, and there's prefix information 2001 DB811, which in the end of the day means the system has two IP addresses, which is the first, well, which is yet another difference to IPv4 DHCPv node. In IPv4, DHCP is what I call an exclusive provisioning system. You either get it from DHCP or from something else, but there is no mixing information. You can't get it like a static information plus DHCP. In IPv6, it's allowed to have many addresses, and those can come from different sources. So let's have a quick look. What about this one? Okay, I would have had to reboot it. But going back to this, now figure there was another system. 2001 DB8 22, and to simplify things, :1 on the same link. So this Windows box, and Bob actually would be 2001 DB8 2001. What do you think? Assuming all firewalls are turned off, which is the case right now, as I will probably provide some additional demos later on, I've turned off anything that could come into play with which could interact with the packets. And now looking at this and keeping this router information, this router configuration in mind. What do you think? Can Alice, let's assume for the moment the Windows system is Alice, can Alice ping Bob? And assuming Bob has 2001 DB8 22:1. Can Alice ping Bob or not? I mean, we could try and have a look at the packets, but I won't, before we do so, let's assume, I mean, the responder might not be there. Still, it might be interesting to see what happens on the packet level once we do this. What do you expect as a potential response if I press enter? What could happen? Let's assume Bob exists with that address, which at the moment it doesn't, but what would happen then? What do you think? Will we get a response? Any takers?
So I would say we send out the solicitation, we get an advertisement, but I think maybe after a little bit predicting local good.
Yeah, that could be the case, but before we do so, I will provide another bit of information. The information provided here essentially says, okay, I have two types of addresses right now. That's the one in the prefix 1.1:1, which is in Windows terms it's public, so it's generated by means of Slack. And then we have a DHCP address, which is the one in that prefix. Matthias, you think neighbors, some type of neighbor solicitation, discovery, whatever related stuff will happen. Any other suggestions? Unfortunately, that's not the case for the reason I just laid out. The L flag is not set in DHCP. If I didn't make that clear, in DHCP, when an address is provided by means of DHCP, the L flag is never set, and you can't configure this. DHCP has no L flag. This probably goes back to the 90s, where the assumption was DHCP is just used in provider in dial-up networks. And in dial-up networks, even though you get addresses from a shared pool of addresses, it's not a shared link. They all go by PPP to a brass whatever. So it's just one-to-one relationships with a router, but not with neighbors. And that's the architectural model which is used by DHCPv6. The L flag is not set, it can't be set. Which means, if I do something like this, I will provide the addresses, and I will just to make things simple, 2001 DB8 2.2:1. Let's have a look. Here we go. We should be good. Let's have a try. What happens is I get back a destination at unreachable. I do not get back a positive response. Okay, the system is not there. But otherwise, it could have been like the standard ping response if I can't reach a system. Here, it says destination is unreachable. Let's have a quick look what happened in the back. Let's stop just for a moment. Here is the ping that was probably the first one that was sent out. Here is some other stuff going on in the back, which is not relevant for us. The interesting packet is this one, is this ping. And there is a number of interesting aspects of this packet. Let's have a closer look at this one. This is a bit unfortunate. The latest version of Wireshark has this default. But the information that might be interesting is all contained in this frame right now. Taking a closer look, is there anything that seems unusual to you? The scenario is, we have Alice, the Windows system, we have Bob. Alice is just pinging Bob. Very simple operation. Very simple thing. There is two things to note in this.
So one source?
Yeah. The first thing is, as a source, 2001 DB8 1 is used, which is surprising, I would say, for the most of you. Why would I ever? I have an own 2001 DB8 2.2 address. I have an address from that prefix. I showed it to you. I mean, I did, but it's simple. But for the outgoing connection to a parent colleague on the same link, 2001 DB8 2.2, I take as a source address. This system, as a source address, takes the one from the other prefix. Can anybody explain this? Oh wait, I have not yet reached the gateway. I'm just in the process. You are, at the end of the day, it's quite reasonable what you say, Andreas, but right now, what a spec does is just build a packet. And I've not even tried to reach a gateway. I've just built a packet. And I built this packet with a source address from the 2001 DB8 1 prefix. Why is that? I mean, that's a bit of a nasty question, as it's very, very difficult to answer. I would be happy, like if guys, if Benedict or Gerd could provide an answer, which I consider.
Well, I would waver a guess, and that's prefix priority for temporary addresses versus settling assignment.
Yes.
That's just guessing.
Yeah, unfortunately, it's the wrong guess. Don't take me on that. For the simple reason I don't have a temporary address. It's a Windows system, but it's a Windows server system. It doesn't have a temporary address. It has only these two. So while it's that might go into the right direction, Gerd, actually it's about somewhat address selection.
Source address selection should find the longest prefix.
Which is the last rule overall in this complex set of rules. The thing is, what if your answer been Benedict?
For this,
6724.
yes.
Yeah, that is the interesting thing. For those of you not familiar with the intricacies of IPv6, in cases where there is several addresses, either on the source side of the communication act or on the destination side, the systems have to figure out. Okay, I have a number of source addresses I could choose from. There might even be a number of destination addresses, like two servers being in a shared subnet. They might be aware of the linked local address of the other server. They might have DNS address, global address from DNS lookup. They might even have several addresses from DNS lookup, including global or unique and a EULA address. So we have a situation where we have to choose. And there is algorithms for this selection, which address to take for a certain communication act. The old algorithm, it's a complex set of rules, which were initially described in ROC, I think it's 3484, which has been superseded by 6724 some years ago. This is in the already a bit unreliable IPv6 space. This is one of my favorite candidates of where operating systems do it differently. They do it unreliably. You can have 10 systems sitting next to each other, 10 times of a day, and you will have 100 different behaviors. It's a complete mess, source address selection. The thing is, it's very, very, even if you go through the ROC, and I have done so several times, if you go through 6724, which is the one that latest Windows systems use, it's very difficult to spot a rule which explains this exact behavior. There is a rule 5.5 which says prefer an address which has an entry in the destination table, so there is a walking next hop over an address which has not a walking next hop. That's 5.5 in 6724. This is the only thing where one could possibly justify this behavior, which is probably, for those of you coming from an IPv4 background, that's completely crazy. Why would I ever take, to reach an address in 2.2, I have an own one in that space, and I take another one. This is where craziness begins. I would be, you know that I'm not the biggest fan of how things work at the ITF right now, or since some years. I would like to go to a 6-man meeting, explain this, and ask, hey, you guys here in the room, 200 guys in a nice Hilton on Hawaii, can anybody explain this to me? As of the ROCs that you have composed. It's a safe bet, 390 pounds. This is so crazy, it can't even be justified from, you might go with 5.5 and 6724 out of 8 rules specified there. That's somewhat crazy, but yeah.
Two questions. I'll start with one. What was route? Route print? What does route print say?
Which isn't actually, that is a very good question. You might be able to answer that by yourself. The interesting thing is that you probably wanted to see. We don't have a local or a linked route for the 2.2 column 2 prefix. For the 1 column 1. We have a route for the local prefix going on. It's on link, and look at this. For the equivalent to this one, for the 2 column 2 is missing.
We don't have subnet mask.
What's that?
We don't have subnet mask for the 2.2.
There is no subnet mask in IPv6.
There's no, in the old days,
not what it is in IPv6. You don't, in IPv6 you don't have a subnet mask and you don't do a logical AND. The only way to find out is the other system I want to talk to on the same link as I is just by means of this flag. And this flag is not set in DHCP. It's never set. It can't be set in DHCP as of the specifications. So once you have an address which was provisioned by DHCP, just to make this clear once more, Alice will be under the impression which is reflected in the routing table. Say this is Alice routing table. Alice knows, oh wait, on 2001 DB8, 1, I have neighbors there, as this address was provided by Slack. On 2:2, I'm alone on myself. And which is why neighbor discovery will not take place. Look at, let's look quickly at the, I said there's two things in this packet which are interesting. The first one is selection of the source address, which is at least interesting. The second one is looking closer. Is there anything else you can spot? Where is this packet sent to actually on the on layer 2? It's sent to the Cisco. Which is the what's that?
That's not surprising.
No, given RFC 5942, it's not surprising. Once I think I'm alone, that's the only party I can talk to. I don't have a route for that network, so I go back to the default route. I have no idea how to find anybody in this network, even though, keep that in mind, even though I have an address myself from this prefix, I have no idea how to talk to anybody else from this prefix, which is why in the end of the day, last resort, send it to the default router. And this is, just to make this clear once again, this is not a bug, this is a feature. This is exactly how DHCPv6 is supposed to work as of the specifications. We will cover this in more detail later on. But you probably already get there are some huge implications of this. An understanding of DHCP that you might have had from DHCP before, and the thing with the subnet mask and the local route, the neighbor discovery coming into play if one's neighbors communicate, all this doesn't exist any longer with DHCP6. With DHCP, the architectural model is every system is on its own. This is reflected by no onlink flag set for the address. Given there is no onlink flag set, there will be no onlink route, which means go to the default route. We will have to see how to cure this in some sense. The interesting thing is, I mean, you might note, you might get back to me like, you know, okay, we understand this, but this is a somewhat strange network anyway. There's a network setup anyway. Why would you have a different address than the address of the default route? I mean, this one has this one is FE80 /1 in my case here, as can be spotted, but the so it's FE80 :1, the link local address, but as you can spot from the configuration, the router interface, the global address is from :1:1. So you might come up with, oh, why use a different prefix for the systems within a network than as a prefix of the router, which could be that would be a legitimate comment. Still, initially I put it up like this to make you aware of the implications of this architectural model of DHCPv6, which are hopefully clear now, and I will get back for a second to this one. Keep in mind, no neighbors on that link, which is why I send it to the default route. And second, this a bit interesting approach to source address selection, which can be with some, you might be able to justify.
It's quite likely 5.5, and there's
Yeah.
a reason why there is 5.5. If you have multiple routers, multiple prefixes.
Yeah, which we can discuss this.
One could argue that your setup is actually provoking this by having no on-link flag. But I would fully agree with you that this is non-intuitive
Yeah.
default.
And it has severe implications that we will see later on. But given there is this comment, it's non-intuitive, we can easily change the setup. What I'm going to do is I will modify it. IPv6, DHCP, full HD, no address, prefix 2001, DB8, 1. Well, no, it was this one. Do not use this one any longer. Hopefully you can already can see this. Do not use this one any longer, but use this one instead. It should be, we would say this, all this looks good. Let's just make sure that's an interface done up. And have a look what happens later on. Do I still have, do you have this? Let's have a quick look. Does this look better from your perspective here now?
It's still non-intuitive because you have enabled at the same time Slack and DHCP.
Okay.
So you told your network to do that, but I agree that this is
Coming from,
not very foolproof.
well, we have another instance where it might be non-intuitive, especially when coming from the DHCPv4 background. But at least the network design is more sound now. They are all on the same prefix. The interesting thing now is, let's have a quick look if these are actually two different addresses provided from two different sources. Which goes like, well, let's 6 show address. It turns out actually we have two different addresses. One is provided by what is called Windows Phone Public, Slack, and the other is provided by DHCPv6. Again, I mean, this might look better, and we might actually try to reach another system now on the link. Yes, thanks for that. That will be interesting. We won't be able to see the very interesting parts right now, but at least what we spot is we have an on-link route for the prefix in question. So we could, I mean, this other system here. I should be able to.
One question though. I can't see all have on-link routes. All addresses.
Yeah. I mean, there is no others from the other prefix now. We only have we have two addresses from the same prefix from two different sources, which might be debatable, but Gerd says that's the way how it is supposed to work.
Well, you configure it that way. I'm not claiming that.
Okay, let's we can. I'm good with that. Let's figure for a moment what happens. We should hopefully. Let me have a check. Yeah. There is another system on the same link, which is this one, running Linux, and we will try to ping an address from that system. It has several addresses as well. Same thing, get an address from Slack, get an address from DHCPv6. And what I'm going to do now is, from the Windows system, I'm going to ping, let's ping this one. This works nicely. So apparently the problem is solved. Once we have a better network design, the problem is solved. There is just one thing which many of you, especially when coming from an enterprise position, might not like, which is that I have two addresses from different sources, which is not, which doesn't make things easier when troubleshooting. It doesn't make things easier when logging correlation and all this. It would be better to have just one address, isn't it? Let's do that. Any suggestions on a technical level what I might do to get to a state of only having one address? Those IPv6 experts in the room. What has to be done?
Get rid of DHCP.
Which is an answer I very much like, but technically speaking, we could try to do this by clearing the PIO information in the router advertisement. Remove the address, the prefix information from the router advertisement will cause the client system not to get any information as for the address from Slack, but will mean just get this information from DHCP. Wait a second. Let me do this. Okay. You might have the right thought.
So
Yeah. In Cisco world, this would look like the following. IPv6 ND prefix, it's about 2001, DB8 1.1. No advertise. Do not put prefix information into the router advertisements. Let's have a look what this actually means for that purpose. Or we will have another interface done up. I will fire up Wireshark as we will need this. And let's have a look what was the impact of this. Oh, this looks nicely. We have just one address now. We are getting nearer to a state which looks like the DHCPv4 like, IPv4 like network. Those of you from enterprise space which have high hopes when it comes to DHCPv6, using this as, in the way you used it before. This is, by the way, we will talk in the second part of the talk, we will talk about expectations. And one of the main expectations from like enterprise people is, it does the same as it has done before. We can use it the same way as we have used it before. One address, one single address, from one single provisioning system. I would say this looks quite good from that angle. Does it? It does. Okay. Now let's go. Then let's have a quick check as for. Let's ping the Linux system again. Let's try if we can reach that Linux system. I didn't touch that one. Well, looks good. Let's have a look at the Wireshark. The thing starts here. From looking at this, is there any packet which seems... Can you spot? Look at what is displayed here. any things that you might find uncommon? I'm asking for two answers. I should do this American, once you get an answer, throw a book, something, stuff, but I want to get two answers. There is a redirect. It's a redirect. Where does it come from? I mean, it's linked. It's local link communication. Alice and Bob. Why is there a redirect? And the second thing, looking close at this ping. Where was this ping sent to? Which is not at all surprising. It's a DHCP provided address. It doesn't have neighbors. No link flag, on link flag, means I'm alone. And I send it to the router, which is, as of the specifications, completely expected behavior. So I send it to the router. Alice sends the packet which is intended to walk to the router. What does the router do? Inform Alice, oh, this was not a smart idea at all by means of a redirect. Which is exactly what happens. Which is exactly what happens and what is, as of the specs, fully correct. But it's most probably not what 99% of enterprise people out there would expect from this configuration. Like, wait a second, a redirect? And those of you who have been in, let me ask you, would you ever trust that an operating system correctly processes a redirect?
No. Actually, I'm surprised to see the redirect.
Yes.
Because the router should know better. The router has all the clients. No, there is no network here, so why is it sending redirect?
Yeah, but the thing is, apparently this Windows system on 17th of March, this system did the correct thing with the redirect, which is learn something from the redirect and adjusts behavior accordingly, as we will see. Look closely at this part. After the redirect, or I hope so, I have no idea, it might have been different, but it should, the next ping which is sent actually goes to the other system. So the redirect was received, it was understood, it was processed, and it changes the behavior of the local system. But this is not self-evident. If you have been in networking for quite some time, redirects are an unreliable thing.
Show me the redirect, please.
Yes.
What's in there for next time?
Actually, it's the redirect in itself. It says, I mean, probably this. Oh, sorry for that. Can't do it like this. So we have the main information, I think, from.
I have the target link there address, which is, I learned something new today.
Which is, I'm happy you did. But all this, ROC 5942. It's all described there. What we see here is the fully correct DHCP behavior as of a certain not so unimportant ROC, which many people do not know. Going back to this, I think you will probably agree with me if I say this one has huge operational implications. And it's widely unknown, and it's widely underestimated. There is a number of people who know, oh, there's something with the on-link flag, with DHCP. But what this means in practice, like this, I don't have a neighbor thing, that has very interesting implications for many networks. Obviously, for troubleshooting, for like, if you have free concentrators with networks like the one of our joint customer, there is these redirects is probably voice over IP networks, like phones, and then they go through ask for a router, and the redirect has to process correctly, which is unreliable. let's get back, before I get back then to what does this mean as for all this. I mentioned several things. What all these might mean for like your expectations, how DHCPv6 behaves. I would like to quickly lay out more differences. The differences I mentioned, no route option, DUID, and this on-link thing. These are technical differences. There is another one which can't be strictly blamed to the protocol, but to the overall architecture. DHCP is not supposed to be mandatory for all IPv6 stacks. I mean, there is this informational RFC 6434, which stands, well, they should implement address configuration via DHCPv6, IPv6 capable nodes. And as of 2119 should means, this word means that there may exist valid reasons in particular circumstances to ignore a particular item, but the full implications must be understood and carefully weighted. So should means do it, otherwise you have to, if you don't have good reasons to do it differently. Can you think of any reasons why a node might not support DHCPv6? Yeah, there might be Benedict.
Resources. When you want to talk about devices, that makes a hell of a difference.
Yeah. Is anybody aware of any vendor which does not support DHCPv6 in their IPv6 stacks? Yes. Android doesn't. And there is a clear statement from Google. As of today, we don't plan to do so. There was a huge bug-like file for Android, which in end of 2014, Lorenzo Colletti, the main IPv6 guy from Google, publicly stated support will be declined until there's a compelling use case. So Google is the opinion that the DHCPv6 is not needed for Android. So once you have an Android device, no DHCPv6. Except for the Fairphone, which is a very special device. But on your standard Android, no DHCPv6, with all the implications this might have on your operations model. And they do not plan to do so, and you should keep in mind, there is people who think that Android will be one of the main platforms for the Internet of Things. So in the Internet of Things, you might have a number of systems without DHCPv6 support.
Small embedded devices,
yeah.
Small microcontrollers. It really makes a hell of a difference. I mean, if you have a couple of kilobytes flash for your program,
yeah.
It really hurts. And there's another problem. It's not that compelling, but it might actually be important. If you have normal people as users and you force them to decide on either end, that's generally a bad move. If you have people who have to decide, should I use DHCP, should I use auto configuration, and they don't understand either one, like the vast majority of people would do. That's also a problem. But
yeah, thankfully, I mean, for like you guys from enterprise space, keep in mind, no DHCP6 for Android, not now, and probably not in the near future. So you might still think, have the hopes of, okay, Enno, thanks for the laying out the stuff, but we still want to use DHCPv6. As we have done this in the last 10 years, we have relied on DHCP, we still want to do this in IPv6. And we have just Windows boxes and iOS, they all are capable of the DHCPv6. So we can use it, isn't it? Well, not quite as we will see. And to understand what are the problems, let's have a quick discourse on IPv6 architectural things, and on and then I combine this with discussion of expectations when it comes to IPv6. In the old days, when IPv6 was mainly specified in the end of the 90s, DHCP didn't have the role it was going to have in large networks. So it wasn't considered important. It was considered like it can be a helper mechanism for certain cases, but not considered a core like element of the protocol. And this exact thing, I mean, one of the consequences is this on-link thing. As the architectural model was, the only people using DHCP are providers providing remote access by dialing. Those guys need DHCP, anybody else won't need DHCP. On the architectural level, one of the main consequences, I already mentioned this, but still it should be kept in mind as it will have influence what I'm going to talk about later. DHCPv4 was meant to be exclusive. Use DHCP or don't. In v6, it's meant to be complementary. It can provide additional information, but it cannot serve as like the sole source of information. Talking about the expectations we see, like in enterprise space, when it comes to DHCP, can be broken down to, we want to use DHCP as a single source of provisioning information. We want to have one single infrastructure composed of n servers and entities, whatever IPAM systems, whatever it might be. We have this service called DHCP, and this is the service which provides information, provisioning information to the nodes in the network. And if it's like one service, there can be one department, one team, one group of people. They might be distributed around the globe. There might be a follow the sun model, whatever. But there is one like organizational entity taking care of provisioning of parameters. You might even outsource the service, but you can identify that single source. Expectation 1. Second, this source is independent. It can work on its own. Okay, you need a working network, but those guys can do their job without depending on other guys. Third, we have an understanding of how things work and should work. We read the RFCs, we listened to stuff like this. Now we understand how DHCPv6 works. It does so in a predictable way. If you have different nodes, different operating systems, a heterogeneous environment, still they all do the same stuff. That's another expectation you might have. We can actually use DHCP in a way that the nodes get provision from the system, and we can once the service is there, it works without that we have to touch every single node. They get this information from the service as long or once we provide it. Last but not least, we can, with reasonable operational effort, we can prevent nodes from getting wrong information, from anybody malicious to interfere with our network or accidental interference. We can achieve like a stable, tranquilo state with reasonable effort. That's what people usually expect from DHCP. And in the end of the day, it can be broken down to, we can run it operations-wise and from an architectural perspective. We can use DHCPv6 like we use DHCPv4. As we will see, and I mean, it's already, I think it's pretty much clear to everybody here in the room, that's not the case. Let's have a quick look at the expectations. We want DHCPv6 to serve as the sole provisioning system. As we already know, this doesn't work given no route option. It can't. That's the way it is. Do not expect this. This will have implications. I'm going to discuss in a second, but for the moment, let's make it clear. There is no single source of provisioning information in the DHCPv6 network. For the simple reason, DHCPv6 wasn't designed to be this system. More focusing on an operational side of things, there might be, okay, but still we can operate with some limitations, but we can operate our provisioning. The provisioning of core network information, addressing information, can be done by like one team or one outsourcing party. No, as there is always an interaction, and a complex interaction, as we will see, between DHCP and Slack. So DHCP will only be able to do its job correctly once all involved layer 3 devices, all involved routers, do their job correctly too. So no DHCP without controlling all routers involved, which, now thinking of global enterprise networks, is not an easy task. Usually there is a number of like smaller subsidiaries or offices around the globe where you might provision them from your centralized IPAM system, but you don't have control over the local Soho router sitting there, which they acquired at a shop next door on the street, or which is run by another outsourcing party, and all this. I can tell you this is a problem we constantly face in global enterprise space. It all depends on your governance model. Yeah.
But I wouldn't argue that this is a particular weakness in this because if you buy a Zoho router who has a DHCP core on it, it will interfere with the operations.
Yeah. Okay, but even if
I agree with the rest that this is
yeah.
not satisfactory.
Okay, agree on that. For the moment, but keep in mind, DHCP will only do its job correctly once there is a correct setup of the corresponding layer 3 network infrastructure, which might be an easy task or not. It's independent. No, we already know it's not. For the simple reason that, and here comes another interesting standards discussion. The usual way DHCPv6 is set up goes along the lines of, on a technical level, wait a second. Within the route advertisements, there is the, in that case, managed configuration flag set. There is a flag within the route advertisements which actually tells the systems, the nodes, hey guys, there is a DHCP server. Go find it and go get information from it. But the initial trigger in most cases that DHCPv6 is used at all comes from the route advertisement, which is probably not new information to many of you. The thing is, there might be differing operating system behavior, as we will see in a second. So DHCPv6 cannot act independently. There has to be somebody else, again, as I said, doing the job correctly, so DHCP can come into play at all, usually. It's predictable. It does what it is supposed to do in a predictable manner. This one is, again, I'm in run mode. In IPv6 world, due to, for historical reasons, for things which haven't been going well in the last 15 years, you shouldn't expect predictability. Do not, if you have 5 different operating systems, 5 different flavors in your 10 or 50K nodes network, do not expect them to behave the same, regardless pretty much of DHCPv6. They might have different approaches to source address selection, they might have different happy eyeballs implementations, they might have different implementations of neighbor discovery when it comes to some specifics. They might have different DHCP behavior. And they will have, as we will see in a second. Even though this might sound funny, it's not. It's a huge mess, and it's a nightmare actually from an operations but one could ask, how could you expect it to be reliable? Looking at the main, at some main statements from RFCs, in 4862 on Slack, there is a statement which reads, even if a link has no routers, the DHCPv6 service to obtain addresses may still be available and hosts may want to use this service. Reading the sentence, one could have the impression like, if there's no router, hosts are allowed to do DHCPv6 on their own without the trigger from the router advertisement. The most common understanding is DHCPv6 is to be triggered by the end flag in the router advertisement. Else do not DHCPv6. Wait until the router tells you to do so. And now this is somewhat makes sense combined with this sentence which says, okay, if there is no trigger by router, if there is no router advertisement at all, okay, no, you may go out for DHCP. And in case, now it becomes interesting, if the same configuration information is provided by multiple sources, the value of this information should be consistent. Well, if I get an address from Slack and from DHCPv6, this value should be consistent, which is what I had in the interim. At the beginning I had not. I had two different, and there were two prefixes. After Gert's polite hint, I corrected this. So I had consistent information. Still there were problems, but right now we have like a consistent state. The point is, this is not what networking in large organizations is about. It's usually there is potential for conflicting information. There is potential for human error. That's where troubleshooting comes into play. So it might be interesting what happens if somebody has committed an error. What happens if there is either conflicting address information? What happens if there is conflicting DNS information? DNS can be provided by DHCPv6. It can be provided by Slack as long as the operating system supports that. RFC 6106 RDNS as option, which all operating systems except for Windows do support. In the end of the day, we did some reality check. Gratefully, mostly Antonius walked in the lab and had a look at how do different operating systems behave in different scenarios. I will get back to this in a second. I'd like to ask a question first. Imagine, and I would like to ask the question maybe to those guys of you who have a very good understanding of IPv6 already, which means feel free, any of you to answer, but I would explicitly look in this direction, guys, Gerd, Marike, Benedict. Imagine a case where there's a router advertisement which has the M flag and the O flag are not set. No M flag, no O flag. But there is a DHCPv6 server on the local link. It is there. It is ready to serve its function. But in the router advertisements, both flags are not set. What are the hosts, what are the nodes supposed to do? What do you think? Any of you?
Observed behavior.
Yeah. It's a difficult question. The most common approach, if you had asked me, like 12 months ago, or 6 months ago, or 3 months ago, actually, if you would ask me today, I would say, oh, wait a second. As long as the M and the O flag are not set, ignore DHCPv6. Which is what Windows 7 does, Linux does, and macOS do. Whereas Windows 8 behaves differently. Once M and O are set to 0, but the DHCPv6 is present, all those operating systems, except for Windows 8, will get the address only from Slack, which is which is correct. Whereas Windows 8 will happily get it from both sources. And this is just one. I won't discuss these things in detail. We have recently published a report with the results from the lab. The main takeaway here is, look at this table. You won't find many cases where the behavior of operating systems is consistent. They all behave the same. There is I think there's very, very few, this is a very easy example. Just O is set, and the MS0 and A is 1. A means a address configuration flag is set. There they behave all the same. In pretty much all other scenarios, they behave differently. There is differences. Yeah.
I just want to make the point that this is extremely important because I think with DHCPv6 and router advertisement, there's so much controversy.
Yeah.
And no matter what you have in RFCs, I think there's guidelines for implementations, and implementations will be different.
Yeah. As we can see here. Which, I'll get back to your comment or question in a second, Benedict. Those of you from enterprise space, looking at this, it makes you like, I mean, this is not what you want in complex network. That different classes of operating systems, when it comes to the core service, this is not very, I mean, DHCPv6 is core service. Address provisioning is the core entity of a stack. That they do things differently. And you might even not expect this between like two flavors of Windows. Windows 7 behaving differently than Windows 8.1. And you might not expect this between different flavors of Linux. And even there are differences looking at this. Even though they pretty much run most of the same kernel, isn't it? Yes. Yeah, they are the same roughly generation of kernel. And still they have differences, which is, I mean, this is a mess.
One explanation why it's different. I've taken a look at this for quite some time, but it largely depends on the DHCP you use. So basically what happens is you process data advertisements in the kernel, but usually not DHCP. You've got a separate routine for that. And depending how that takes, there's a good chance it will ignore data advertisements because it doesn't care about it, because the kernel can express these things, and then this mess gets really ugly.
Yeah. Which is, I mean, again, there can be a technical explanation. One might be able to find out by going through kernel documentation or, say, system process, one might be able to justify any of those by digging deep enough into, like, the technical documentation. From an implementer's perspective, that's a mess. I don't really I don't really know what this. We were I can say we were shocked, weren't we?
Yeah.
I mean,
I had to run several tests twice and third time just to be sure because some of them seem so strange.
yeah. But this is reality, and we tested. He's a very scrupulous guy when it comes to testing. Yeah, reality check. Predictability does not exist.
Favorite test, since I'll be at the IATF next week, I would love to go to one of the sessions and just go, why?
Yeah. I'll tell you what would happen. Who's the guy, NRI? He hasn't been here for the last 10 years. He's not credible. This is what's going to happen. I'm kidding somewhat.
But this is why you send Marika.
Yeah. And then, yeah. I'm happy. You will be our mediator. Yeah.
Actually, I would love to because this is ridiculous.
Yeah, it is. And the funny thing is, there is this draft V6 ops DHCPv6 flag problem. They have a similar table in the appendix. So those guys, I think Fernando was involved. They run similar tests. They had a bit different scenarios. We have more scenarios, especially we have more scenarios. We did look at scenarios with two routers. In addition, emitting conflicting information. One router emitting router advertisements with an M flag and the other without. And there are all types of strange things happen. Like systems get a router advertisement which tells them use DHCPv6. So they run a code DHCPv6 info and learn it. And then there comes the other router advertisements a router advertisement, and then, like 10 seconds later, which tells, oh, there is no DHCPv6. Then they forget the DHCPv6 learned information, like DNS. And another 10 seconds later, they learn it again. Now think what this means for troubleshooting. For the guy calling a help desk, service desk, oh, internet doesn't work. Could you please press F5? Well, okay. Now it works. Oh, I'll hang up. And then another 10 seconds later, press F5 again in the browser, and it doesn't work. And I mean, this is an easy scenario. So it's a mess. Predictability, you should not expect that. I will lay out what this means as for your configuration approach or for your expectations. I'm still a bit on expectations at this stage. But I don't want to leave you like with this round and it's all broken and it's all messy and whatever. Unfortunately it is. But let's think about for a second.
Excuse me for the direction.
Go ahead.
Just to mention that in this test, we also had the RDNSS information in the
Yeah.
advertisement. And there was also similar mess with the DNS servers.
Yeah. There is.
Their priority, etc.
Yeah, we just tipped like the how do you say, the tip of the iceberg. Or, when I mentioned this, there is much more mess in all this, which you can read in the report that Antonius maybe Antonius authored. Okay, what does this mean? What type of advice does this mean when it comes to practical implementation? Let's have a quick look at what we expect from DHCPv6 to do. One parameter system, everything that's needed, centralized way, it's independent, it's predictable, it does have some DHCPv4 properties, which is understand the MAC address, be able to perform reservations. We want a similar local link behavior, and we want to prevent rogue players. How would we do this, or which of those can actually be fulfilled by which technical means? That's what I'm going to cover in the. I will go a bit over time. I think we started lately. We started a bit late, but I will need another like 10, 12 minutes. As for this sole provisioning thing, this can only work or have the DHCPv6 as the main source of address provisioning information and the main source of like address tracking. And where would have a look once you have like Miracle laid out, like you have an incident and you want to see who was that actually. Where would you look at? Probably DHCP. This is why a number of organizations want to use DHCPv6. Well, this means if you want to achieve this objective, you must be able to have control over the involved L3 devices, either by technical control, I will lay out this in a second, or governance and guidance. Be able to distribute like a one-pager in the course of the IPv6 transition efforts that we as large corp are currently undergoing. Please, all local IT entities, take care that whatever you do, that router advertisements are configured along these lines. So you might do it within the organization. You might try to put this onto the outsourcing party, like talk to whoever systems. We expect you, now that you have won the 350 million contract for the next 3 years running our global network, we expect you to have a consistent configuration approach to all layer 3 devices. Have fun with that. If, or provided you have this level of control, the thing that has to be consistently configured is the M flag must be set. Otherwise, all systems except for Windows 8.1 will not use DHCPv6. So M flag is a prerequisite. Then what one could do is either clear the PIO, the address information as a whole. So that was necessary for having just one address. The problem is, we still have this somewhat strange behavior. Right now on the Windows system that I have here, while I only have one address, which is what I actually somewhat wanted, in the end of the day, I want the same thing as in DHCPv4. One address which is good, but there is this redirect thing, which we haven't cured so far. But this is what has to happen, like on a technical level, and this can only be enforced on the infrastructure level. There might be people who ask, like, okay, if we can control the infrastructure, can we do it by controlling the nodes? Like, can we put out a group policy telling all Windows systems, at least, that they should not use conflicting information, or they should all behave like Windows 8.1 do, or DOS, or Windows 7. Unfortunately, I'm not aware of any tweaking of this behavior on the node level. Well, to be able to use DHCPv6 as a single source of provisioning, you must do all the above and send people to the IPF. Right now, I mean, Hawaii is a nice place, isn't it? And Dallas is not too bad either, I think. And all these Hiltons and Intercontinentals are nice hotels. So get your boss.
Oh, but I gotta tell you, going to the IPF is terrible because you're in Hawaii and you're losing the entire day and everybody else goes to the beach. But you know, I do want to mention, I mean, I have friends who can't travel, you know, because they're sick, ill, whatever, and they participate with level. The problem with the IPF is it takes a lot of time, and it's also a lot of personal time, right? I mean, a lot of people do this as volunteer work, not necessarily always for their jobs. And you can read documents, you can participate in this, and I actually was encouraged to do this as well, because you do not have enough operators in certain countries.
Yeah, and there is, I mean, I think enterprise is heavily underrepresented at the ITF, but, well, I've stated this, thing for this IPv6 summit. I've stated it often enough. Run DHCPv6 in a centralized way. What we strongly recommend, we at ERNW, given we mostly work in very large environments, and I myself and many other guys of ERNW, we are not big fans of like addressing process problems by means of technology, like bring in yet another appliance to solve a certain problem. Actually, we in many environments recommend against this. We tell them like, no, don't solve the problem by buying yet another tool. Get your homework done first and other stuff. But there is one exception from this overall position, which is for IPv6. We strongly, strongly, strongly recommend having an IPAM system. Don't ever think, and I mean, we are completely vendor independent. We don't have partnerships, whatever, gold. We don't sell hardware, we don't sell software, we don't sell anything except for our expertise. But still, without an IPAM system, don't think about large-scale IPv6 deployment. And that IPAM system has to support a number of IPv6 properties, which we have laid out in the document. We recently published a report on what we think are reasonable requirements when it comes to IPv6 for IPAM systems, and we had a look at several market-lead solutions. All this in an independent manner. No window involved, no money involved, nothing like that. You can do whatever you want, but you need an IPAM, and you need one that is suited for IPv6, which, as of the current market players, not that many are. And especially you might be aware of the, those of you running the Alcatel-Lucent solution, XQIP, I think they're called Vital IP now. From what we looked at, they don't have very good, at the time when we looked, IPv6 support. And the point is, there's all these rumors, will there be, I mean, Alu sold that to the Chinese, but kept Vital IP in-house. keep stuff like this in mind. You will need such a system for the next 5, 10, maybe 20 years. Do your homework when evaluating such a system. That's the message of this talk. Just a slide here.
Did you include Six Connect in your paper?
What's that?
A company called Six Connect?
No, I've never heard of them. I mean, we did, what do you do on like the enterprise side? Look at the Gartner report, look at who has which market share. We picked like the top 5 and we looked at those.
They're smaller, but it was
Yeah.
about 5 years ago, and somebody
Okay.
was helping people deploy IPv6
Yeah.
and NPNSec, and so it's something that I
Okay.
just have people
Yeah.
look at. Yeah.
Thanks for the hint. To be honest, I wasn't even aware that they existed.
It's Six Connect. The number 6 and the word connect. Yeah.
Thanks for that. We already had this one, like DHCPv6 expectation is works independent of other mechanisms that won't work out. Forget about it. Predictable. You have to understand of the main nodes which are represented in your network, how those behave, which means test lab, homework. We think anyway, test lab is a very important investment when it comes to V6 planning. But you can't tweak like the node behavior, but you must still be able to understand it in the way like doing the same stuff that we did in the lab, or read our report, read that IETF draft, try to figure out what happens. Last point, what about those we wanted, at least on some technical level, to behave like DHCPv4? This can usually be broken down to the stuff relating to the MAC address, like reservations or some access control based on the MAC address. And still we have this kind of unsolved problem of the on-link behavior so far. As for the MAC address, there is a relatively new, albeit it's like 39, like 2 years old. It's not that new, but still there is an RFC which describes, look at this, client link layer address option in DHCPv6, which lays out that relays, this is about relay, but then it applies to pretty much all large organizations, that relays can include the MAC address. I mean, a relay knows the MAC address of the client, as the relay is on the same local link. They can extract the MAC address and put it into the relayed DHCPv6 the packet they send to the actual server. So the server can learn the MAC address, and then decisions can be taken based on that MAC address. Reservations, logging, whatever. So far, 6939 is not widely supported. We are aware that ISD DHCPv6, DHC daemon since 4.3.1. Right now we are at 4.3.2, just recently released. So relatively new versions of ISD do support it. Probably IFM solutions which have ISD as the technical underpinning will support it at some point of time. When it comes to the relay level, Cisco iOS XE routers do it by default, which is very good. Not common iOS so far, but XE devices they put, when they act as relay, they put in this option. And actually, we went into the lab, again it was mostly Antonis who did the work. We have a blog post describing the concrete setup. We got it working. We managed to implement the network with RFC 6939 based reservations. But support is not yet widely there. But there is a cure, there is hope when it comes to this stuff. And then we have this thing with the redirects that Alice and Bob do not think they are neighbors. even though maybe on a like network implementation level they are. This cannot be cured on a DHCPv6 level. It cannot. This is expected behavior as of the specs. There's nothing you can do about this. But there is one trick. Actually, I mean, relying on the redirects is probably not what you want, for many reasons. Network operations and troubleshooting level, this is not feasible. But you could do, let's call it a trick. Ivan would probably say a dirty clutch, which goes along the lines of, even though an address is provisioned from DHCPv6, you can tweak the router advertisements in a way that they essentially do the following. The router tells the nodes on the link, like, hey you guys, I have address information for you. So leave the PIO option within the router advertisements. Prefix information is in the router advertisements. But I just tell this you are not supposed to use this for address auto configuration. I'm just telling you so you have an idea that, as I told you that, you are neighbors. Sounds intuitive? It is intuitive. Oh, no. That is somewhat crazy. Next generation internet protocol. To make you get into a state in a DHCP provisioned network, let me put it technically, with one address that you got from DHCPv6, to make you dispose or display an Ethernet-like behavior. Essentially, it goes like, DHCP told you your address. I will tell you something about the address too, but just don't use it for configuration. Just keep note of it that, as I told you, your neighbors. That's actually on Cisco, it looks like this. Once the configuration, once you do not use, once I replace the thing that I have, actually, it would go very quickly like this. Get rid of this one. But hopefully it's no, it's not the same, but I will correct this. Once I go with the config, it's a full command. Once the config looks like this, what is actually going to happen is that the router advertisements latest version of I just want to see the where's the capture. Is anybody familiar with the this version of where do you get my captures from? This is yeah, that's thanks for that. That's a good idea. Actually, now the router advertise probably might we might look at this one. So the thing is, there should be no, that's an old one. Good point. Given I put in an here, so now the route advertisements look like there is prefix we will see there is prefix information but the A flag is set. Do not use this for address configuration, but still the L flag, the A flag is not set, the L flag is set. So now this tricks the actual nodes into behaving the way they did in before DHCPv4 provisioned networks. Now they will do neighbor discovery. There won't be this redirect thing. So it can be, from a technical perspective, this can be solved. But obviously this means you have to do this if you want a consistent behavior, to do this on all routers involved. And they all have to support this. I mean, on Cisco, that's the command is not widely known, but you can do it. Do not expect to be able to do the same thing on like a Soho firewall, which you might have in small offices or so. The devices, I mean, I checked on ASA, I checked on Checkpoint. They all, once you figure out how, it might mean digging in the knowledge base, that they can all do this, but it has to be done, and it has to be done consistently. Last but not least, and that is pretty much like promise, 5 minutes we will be done. Last thing I want to mention, what about like if you don't want rogue DHCP information to be spread throughout your network, there is a feature called DHCPv6 guard, which is the equivalent to DHCP snooping in IPv4 networks. The problem with DHCPv6 guard, there is a manifold problem. First, it's, the platform has to support it, which many don't. It doesn't have a really intuitive configuration once you do this. We wrote a blog post, and funnily enough, we wrote a blog post, and that one, Christopher did this. And even in that post, we had a somewhat dubious understanding of what the actual, this is part of another configuration set, what this actually does. And just recently, a really smart guy, I know him personally from another organization, he posted a comment laying out that our understanding wasn't correct, and he's right. So DHCPv6 guard is a bulky thing, a bit, and it has limitations. DHCPv6 guard, I put in the appendix some slides that Antonius did. Actually, DHCPv6 guard can be circumvented in the same way as RA guard can be circumvented. In some sense, even easier, as you don't have to add extension headers. Just once there's 2 fragments, and the DHCPv6 information is in the second fragment, which can even be done without extension headers, DHCPv6 guard is blind. So it doesn't really help against like a determined attacker. And Antonius, his tool, Kron, in the interim, the new version, which will be released today, isn't it? Is that not for the lunch? Yeah. That one has, it can be done easily. He will show in his afternoon workshop how this can be done. And the thing is, now Eric, would come up like, oh, you should use an ECL then with undetermined transport or something. The thing is, even this ECL can be easily circumvented once you add a number of destination options headers, and then the ECL, the ACL is blind. So you can't, when it comes to a determined attacker, you can't really prevent against rogue DHCP. You can still prevent the accidental case, which is a good thing. Like people firing up a virtual machine with DHCPv6 running for testing purposes, and then these confuse your network. You can do this, but when it comes like to somebody who wants to interfere with your DHCPv6 operations as of current configuration, we can't do anything except for Toby has another advice.
No, what I was just about to say that because what I encountered in customer networks is this accidental thing.
Yeah.
Most of the time
Yeah.
what causes confusion, what
Yeah.
causes errors, and in that way, using those functionalities that are built in, it's a good way to prevent
Absolutely.
errors. Because if you really are a determined attacker and you are already in the local network,
Yeah, then
insert
it's
something,
game over anyway.
then it's game over anyway.
Yeah.
So,
It's just this is to make like transparent what it can, what works and what doesn't. So for the we still recommend. I mean, once you have understood the way how DHCPv6 guide is applied, then put it in like your templates and roll it out. So for that purpose, it's to prevent the accidental case. Good point.
And in any case, when you talk about security, just relying for to mitigate something with
Yeah.
just one feature is always a bad thing. So if you don't have appropriate monitoring in place that tells
Yeah.
you, hey, there is another guy checking those packets,
Yeah.
so that you have visibility into your network,
Yep.
you're anyway.
To summarize, if you want to strive for, if you still, after the presentation, you're into, we want to use the DHCPv6 in our network. To get to the best possible like state of meeting expectations and objectives. Here is a quick summary what you should do. You have to control 3 devices, otherwise you will have a mess. Tweak the config, take care of RSG 6939 support, implement an ITAM, use this feature if considered appropriate when it comes to operational resources versus extra security benefits, then you might send people to ITAM. To conclude, DHCPv6 very different from DHCPv4. This has huge operational implications, and you must carefully evaluate and thoroughly understand how this stuff works, as probably you have one of the main takeaways from this presentation is it's very different, and it's somewhat a mess. Thanks for listening. Bye.